No, right, you can't speak to.
Alright, so let's take a flashback here. When we first started doing antiderivatives, we had a little introduction to differential equations, and we practiced that, right? We said that if I had a derivative of something and I wanted to go back to the original function, in order to do that, I needed to integrate that function, right? It should give me back to the original function. And that's exactly what we're doing when we're solving differential equations, because all it means is that it's an equation with a what? With a derivative, okay? Or it's an equation of a derivative of something. And most of the time they're asking you to go back to the original function. Sometimes we had to do this when we were doing position, velocity, and acceleration, right? We had acceleration, we had to go back to velocity, or we had acceleration, we had to go back to position. Alright, so we did a little bit of this, but I just want to recap and remind you. So we rewrote y prime as dy dx, and then we had to separate the variables so that way I could be able to integrate it. I wanted the parts that had x's to be with the dx, the part that had y to be with the y. A lot of these problems were very simple and they only had x variables in them, so you didn't really have to think too much. But on the AP test they will have a mixture of them. Right? Now when you integrate both sides, this side gave us a c, and the other side also gave us a c, right? But when we minused it, we said that these two together is just some other constant, right? So I think after we did this first example, from then on, we didn't put the plus c on the left side anymore because we knew that it was eventually just going to be plus some big constant altogether. Do you remember that? Okay, so I want to make sure we do remember that because I'm going to do that today. I'm not going to be putting plus c on both sides. I'm just going to put it on the left side. And I hope you remember why. Yes? Cool?
These are old notes, right?
These are old notes, yeah. Right? And then we talked about these solutions being called general solutions, right? Because they have that plus c. And then we also talked about solutions that were called specific solutions. In order to find those, we needed some extra information, like a point, right? And then using that point, you can find the specific c that satisfies that equation, and then go back and plug it in and write your equation. That would be the specific solution, or sometimes on the AP test, they call it the particular solution. Is everybody okay? This stuff coming back to you? Sort of?
It's after you integrate, then you plug in the point.
After I integrate, then I can plug in the point so I can solve for that c. Then once I know c, I can go back and plug it in to know the specific solution.
Oh, that's like a long time.
Was that a long time ago? Yeah, I don't put dates on my handouts, so I don't know, but I would have to check my YouTube videos. But I don't know if you remember, we had to do it several times. Like here we started with the second derivative, so I had to find two different c values, right? To be able to write the original function. We do this a lot in UIL. There's questions that usually come up. Cool?
Really?
There will be one of these on the AP test, so you do need to be familiar with it. And it's not going to be a little kindergarten baby problem like the first 6 that we do. It's going to be like the last one, 7, 8, 9, and 10. Alright, so the first 6 are just for us to get warmed up and get a feel for it. And then once we get to the other ones, we'll crank it up. Sounds good? Yes? Alright, so the basic idea is to solve that differential equation, go back and find the original equation. Okay? Now if they ask you to find a particular solution, because they provide you with that information, you find it, most of the time they do ask for it. Okay, this is being able to find that particular solution, being able to do just that part A is worth like 6 points on that free response question. Okay, this was like question number 4 on the mock exam that a lot of you didn't do because we hadn't talked about it. So maybe after we do it, you should be able to go back and do it. Okay, so the first step is to separate the variables, meaning get the parts with y's with the dy part, get the parts with x's with the dx. Okay. Second step is to integrate both sides. And you get points for doing each of these things. So if you get to a point in the problem where you can't continue, do as much as you can so you can get individual points for those individual skills. Right? The third thing after you integrate is you're going to have your general solution. Now if they do provide you with information like here, they gave us the point, then you want to go further and find that particular solution by finding that c and then replacing that c in the general solution. Sounds easy? Yeah? I think it is. Let's give it a try, okay? So notice here I have dy dx equals this. This guy, in order to integrate him, I need to have that what over there? That dx. So I can multiply by dx, and he's over there. So now I have dy is equal to 6x squared plus 6x plus 2 dx. What's the number that's next to dy?
1.
A 1, okay? So we separated the variables. Check. Step 2, integrate. Remember, the whole point of this problem is to find out what the original equation was. What was y? I want to make it y equals, not dy dx equals. So what do I get if I integrate 1 with respect to y? Y. Okay, now integrate the other side. X to the third, divide by 3. 6 divided by 3 is 2. Plus x to the second, divide by 2, so we get 3. Plus 2x plus 1 big C for both sides, even though I integrated twice. Are we okay? They're not going to take off points because you didn't put plus C and plus C on both sides on the 8. Alright, so that is my what solution? General solution. Now I want the specific one. Okay? Because they gave me information for it. So what do I have to do? Find C using the given point, which is negative 1, 2. So 2 is equal to 2 times negative 1 cubed plus 3 times negative 1 squared plus 2 times negative 1 plus C. What are we going to get when I do that? Negative 2 plus 3 minus 2 plus C is equal to 2. So that's negative 4 plus 3. Negative 1. When I move it to the other side, I do plus 1. So I get C equals what? 3. Are we okay? Can I write the particular solution now?
Yes.
So I'm going to come from here, and all I'm going to do is replace what? The C. Finish. Too easy? How can I check my answer? We can plug in negative 1 and we should get a 2. How else can I check my answer? Find the derivative and see if we get what? That derivative, right? Now we might get, there's different things, right? This could have been a 5 and we still get that derivative, right? So you've got to be careful, okay? Cool? Try number 2. Is that one ready to go? All the stuff with x's is on this side, so I need to move that dx over there, right? Now it looks really ugly, so I don't know. You tell me what you want to do. I get dy is equal to what? Could I send this guy up? And can I take out the 1/2 like this? 1/2 x to the negative half times 1 plus 12x to the 3/2 dx, because I multiplied by dx in my head. Are those two equivalent or no? Yeah? Okay. And then what could I do before I actually integrate? Distribute this guy? So I get dy is equal to 1/2 x to the negative half plus, what's that, 6?
Yeah.
When you multiply, add the exponents, so 3/2 minus 1/2, 2/2, which is x, right? dx. We're ready now? So let's do it. Integrate both sides. When I integrate the left, I get y, right? Equals. Add 1, so we get half. Divide by half, there's a half, so it's 1. Plus x squared, divide by 2, we get 3. Plus what? Did they give us information to be able to find a particular solution?
Yeah.
0 equals.
Yes, so we need to find it, okay? So we're gonna find C using what? The given point, which is 0, 2. You with me, Martin?
Yeah.
Alright, so let's do it. Plug in 2 for Y. That's equal to 0 plus 0 plus C, right? So C equals what?
2.
2. Can we write our particular solution? It's going to be Y equals the square root of X plus 3X squared plus
2.
Too easy? Probably the hard part was here, getting started. Right? I'll do them. Let's check this one out. What happened here? Oh no, now I got 2x over y, now I got 2 letters. Oh my god, no way!
Ah, it's the end of the world.
It's the end of the world. We're all gonna die. We're all gonna laugh at me. We're all gonna laugh at me. Alright, anyways.
What?
You ever seen Carrie?
No,
Yeah. I didn't see this. Good movie.
I haven't.
Not the original?
Yeah, so the one where they make fun of her when
Much
she
scarier.
showered.
Alright.
The one more scary.
Pretty messed up.
Yeah,
Created- Yeah, everyone makes fun of her.
so, we want to separate the variables, okay? So what would we end up? Could we do like cross multiply here to kind of take
You're
care of that?
asking for it. You're asking.
Yeah? So that would be like y dy is equal to 2x dx. So doing cross multiply on this one takes care of that issue. The variables are separated, that's 1 point. Can you believe that? You get 1 point for doing that,
Easy.
right? Everybody better get that 1 point. Okay? Second thing is to actually what? Integrate. Now if you integrate correctly, you get another point.
Whoa.
So hopefully we can do that too. So what's the integral of y with respect to y? Add 1 divided by the new power. What do we get? 1/2 y squared is equal to x squared
Plus.
plus c.
That took us a while.
That took a while, yeah. Come on, let's go. Step it up. We haven't even got into ln's and e's or u substitution or any of that stuff. It's gonna be there. Okay? So separate the variables, check. Integrate, check. Does it give us enough information to find a specific solution? No, they didn't give us a point on this one, right? So here we're gonna stop. This is what we would call the
General solution.
general solution. Okay, you do not have to make y equals. Okay, you can leave it like that.
Which is fine. If they did give us a point, we have to solve for y.
You would have to get the c and then continue. Okay? And then you would run into an issue because when you solve for y, right, you're gonna get y equals what? What are we gonna eventually have to do to get rid of the square? We're gonna have to square root, right? When we take the square root, we're gonna have plus or minus. So then we're gonna have to know which one is it? Is it the plus one or is it the minus one? So what do you think would help us to figure out which one that one would be? Right, the given point, right? So we'd use that given point and pay attention to the y value. And if the y value was positive, then it would be the positive one. If the y value was negative, then it would be the negative one. That would be good. Okay, that's why here we can't go any further, because we don't know C, so we don't know which of the two it was going to be. Okay? If you wanted to go further, you could, but you'd have to put that plus or minus. You wouldn't be able to eliminate one of them. Cool? Let's try number 4. This one does have enough information for the particular solution. Way too slow, we gotta step it up. So separate the variables. What do I have on the left? 2y dy equals?
X squared plus 2x dx.
Awesome, 1 point. Woo! Let's go So let's go. And you need 49 more for the 5. Okay, next step, what do?
Integrate.
Integrate. Okay, so I'm going to integrate 2y dy equals the integral of x squared plus 2x dx. And I'm just rewriting it on purpose. On the day of the actual test, you don't have to do that. Okay. So what do I get? Y squared equals 1/3 x cubed plus x squared plus c. Okay. So they did give us enough information, so we do need to find that specific or particular solution, right? So in this case, we need to find c using the given point, which is 0, 2. So plug it in. So we get 2 squared is equal to 1/3 times 0 cubed plus 0 squared plus c. So that's 0, 2 to the second is what? 4, so we know c is 4. Let's write our particular solution. So we're going to get y squared is equal to 1/3 x cubed plus x squared plus what?
4.
4. Okay? Now, when you're finding particular solutions, we cannot leave it like that. We actually need it to be y equals, okay? So right here, you want to make a note. Must be y equals. Okay, you can't leave it like that. So we know that we've got to take the square root, and every time we take the square root, in the next step, we have to put plus or minus.